Hi everybody, welcome to Mrs. John's Year 12 Physics lesson. This is the first lesson, which is an introduction to static electricity. This is part of your electricity and electromagnetism achievement standard. Now in this lesson, I'm just going to talk about a couple of things. One is about charges and about electric field and electric field strength. So there are two types of charges. You've got your positive charge and your negative charge. And you also know from before that if you have two similar charges, they are going to repel each other. So if you bring two positively charged objects together, there's going to be a force of repulsion between them. On the other hand, if you have opposite charges like a positive and a negative charge, they are going to attract each other. And that's the law of electric charge. Like charges repel and unlike charges attract. Now just going a little further, the symbol for charge is the letter Q. So charge, which could be positive or negative, is represented by either a capital Q or a little q. Okay, and charge is measured in a unit called coulomb. And that's represented by the letter C. Now the smallest unit of charge is the charge on an electron, which is the same size as the charge on a proton. And the charge on an electron is given by Q is equal to negative 1.6 times 10 to the power of negative 19 coulomb. And a charge on a proton, also it's positive, it's the same size. Now these numbers will be given to you. In order to find out how many electrons make up 1 coulomb of charge, what we need to do is the number of electrons in 1 coulomb of charge. In order to find that, what we do is 1 divided by 1.6 times 10 to the power of negative 19. We're going to get a very large number. That is the number of electrons that make up 1 coulomb of charge. Okay. Now, we usually have a plus sign to represent a positive charge, and we have a minus sign to represent a negative charge. Now, around every charged object, there is what we call an electric field. These are electric charges, so around them there's an electric field. So how do you define an electric field? It is the area around a charge or a charged object where another charge would feel a force. So every time you use the word field, you need to bring in the word force as well. So these two words go together. And electric field is represented by what we called field lines. Now field lines are drawn to show the direction of the electric field, and it's actually radial around a point charge. So they kind of look the same, but the difference is the direction in which they go. So field lines go out of the positive and into the negative. Okay, the direction of the electric field is defined as the direction in which a positive charge will move. Okay, now the next thing, and then the concentration of the field lines tells you how strong the electric field is. So the closer they are together, stronger the electric field. The further apart they are, weaker the electric field. Now the sort of electric field that you need to learn in year 12 is to do with a uniform electric field. So I'm just going to talk to you about that. So the word is uniform. Uniform means same. So you have a uniform electric field if you have two metal plates that are parallel to each other, and each metal plate is connected to the terminals of electric supply. So, you know, the long line represents the positive terminal. So whichever plate is connected to the positive terminal is going to get positively charged, and whichever plate is connected to the negative terminal is going to get negatively charged. So when you have two plates parallel to each other with opposite charges, you have between the two plates what we call a uniform electric field. And this uniform electric field is represented by evenly spaced parallel lines. So it's evenly spaced within it, but outside it's not uniform, so the line is curved. We also need arrows, so arrows go out of the positive into the negative. Make sure there's no gap between the line and the plate. It needs to touch the plates. Okay, now we have something called electric field strength. How strong is the electric field strength? Now, in a uniform electric field, this electric field strength is the same everywhere. That's why it's uniform. It depends on two things. It depends whenever there is two plates opposite each other with opposite charges, there is what we call a potential difference between the two plates. And this electric field strength, it's a vector because it's got direction, depends on the voltage or the potential difference between the plates and the distance between the plates. How far apart are the plates? So just looking at this formula tells us you can have a stronger electric field if your voltage across the plates is greater or it's increased, and also if you bring the plates closer together, when distance d decreases, electric field strength is going to increase. So there's two ways of changing the electric field. Now, because of this formula, you have one possible unit for electric field strength. Voltage is measured in volts, distance is measured in meters. So the unit for electric field strength is volts per meter. So that's one unit for electric field strength. There's also one other way of defining electric field strength, and that has to do with the force that is felt by a charge that's in the electric field. So what do I mean by that? So if you have two plates opposite each other, the plates could be horizontal, it could be vertical, it doesn't really matter, okay? So long as they have an equal but opposite charge, there's electric field between them. So if you have introduced a positive charge between the plates, you could have a positive or a negative charge. What's going to happen to this positive charge? You know, like charges repel and unlike charges attract. So this positive charge is going to move towards the negative, or it's going to accelerate towards the negative charge because it feels a force. Okay, now that force, the size of that force depends on how strong the electric field is. So if it's a stronger electric field, it's going to feel a stronger force. So the other definition of electric field strength is to do with the amount of force felt by charge. This is your electric field strength, has to do with the amount of force felt by charge. Charge is represented by Q. Now, because we have this formula as well, there's one more possible unit for electric field strength. Force is measured in newtons, charge is measured in coulomb. So another unit for electric field strength is newtons per coulomb. And that's my first lesson, an introduction to static electricity at year 12. And I hope that helped. Bye for now.